All right, let's try answering question number 1 here. If you haven't done it yet, you can pause the video here and go download the PDF of these questions. Check the link in the description below. All right, let's continue on now. So question 1 asks us to use the graph here on the right to compute the average acceleration between a couple of different time intervals. So let's start out with the first time interval. Okay, we're looking at t equals 0 and t equals 6 seconds. So t equals 0 is going to be here, and t equals 6 seconds is going to be here. Okay, so how do we compute the average acceleration? Remember, this is a velocity versus time graph. Well, there's sort of two ways that we can do this. We can use the equation for the average acceleration, and that's going to be the change in velocity over the change in time. Or we can look at this graph and we can try and plot a line between these 2 points and compute the slope of the line. But if we compute the slope of the line, we're going to see what we're actually computing is the change in the vertical axis. So that's going to be this quantity here, which is the change in velocity, divided by the change in the horizontal axis, which winds up being the change in time. And so we can see that's exactly the same equation that we have here. So actually doing it both ways, we're going to compute and get the same result. So let's do this. The change in velocity is going to be equal to v2 minus v1, and this is going to be over t2 minus t1, the change in time. Okay, what's the change in our velocity going to be? Well, our final velocity here is 15 meters per second, and our initial was 0. And for time, our final time here is 6 seconds. And our initial was 0. So if we do this, we get 15 over 6. And if we compute this, 15 divided by 6 is 2.5. Okay, so let's write this as 2.5 meters per second squared. That's going to be our final answer here for the average acceleration between t equals 0 and t equals 6 seconds. Okay, so let's try another one here for t equals 7 and 10. So here's 7, and here is t equals 10, right? So what is the average acceleration going to be here? Well, if we look at this line here between these 2 points, well, what's the slope of this line going to be? We can see that it has a 0 slope right here. Because there's a 0 slope, we see this is going to have an average acceleration of 0 meters per second squared. Another way to look at it is the change in velocity is going to be 0, right? So it starts at 25 meters per second and it ends at 25 meters per second. There is no net change in velocity. So that means there's no acceleration, 0 acceleration. Let's look at this next one here. So we're looking now between t equals 2 seconds here and t equals 13 seconds here. Okay, so these are further apart. And although the velocity winds up changing a lot in between these 2 points, we're concerned about the average acceleration, right? And for the average acceleration, all we have to do is look at the starting point and the end point. And what we can see here is, again, we have a 0 slope for these 2 points, the beginning and end point. And so our acceleration, again, is going to be 0 on average between t equals 2 and t equals 13. Now, if we had changed this a little bit, if we had started, say, at t equals 2 and ended at t equals 14, well, now the average acceleration would no longer be 0, right? Because If we connect these 2 points, we can see this is not a horizontal line anymore. This has some small negative acceleration. So we could compute that and we would get a slight negative acceleration. So it all depends on where we're determining our first and final points, right? The beginning and the end, and what the slope is going to be for the line connecting these 2 points. Okay, so that's sort of how we do that. And now we want to look at part B. What is the instantaneous acceleration at t equals 8 seconds? Okay, so if we look at t equals 8 seconds, that's going to be right here on the curve. And for the instantaneous acceleration, we want to find the slope of the tangent line to the graph at that point, right? That's what we want to do. So we're looking for a of x here, and this is going to be the derivative of the velocity versus time graph. And this is essentially the slope of the tangent line to the curve. Now, if this was a smoothly curving line, we would have to sort of figure out what the tangent line is. But because this graph here is perfectly straight as it goes through this point at t equals 8 seconds, we can easily find the slope of the tangent line. It's going to be the same as the slope of the curve at that point, and the slope is 0. So this is 0 meters per second squared. Our instantaneous acceleration at t equals 8 seconds is 0 because the velocity is not changing before or after it. It's staying the same, right? Same velocity, 0 delta v, 0 acceleration. All right, and let's look at t equals 12 seconds. So t equals 12 seconds is going to put us just about there on the curve. And again, we're going to be looking for the slope of the tangent line. And again, the tangent line here, because this is a straight line curve, the tangent line is going to have the same slope as the curve at that point. So what we can do is we just need to find the slope of the curve over here. And we can sort of choose between a lot of options here where we want to have the first and final points to determine the slope of this line. I'm going to choose, let's say, this point here at t equals 10 and this point here at t equals 15 because they're furthest apart, and it's just sort of a good practice to try and choose your boundaries far apart when you're doing experiments, because then you sort of reduce your experimental error. So it's just a good practice, but you could have chosen, t equals 11 and t equals 12, or t equals 11 and t equals 14. Any of those start and final points would work just fine. But let's go with the ones that I chose here. So what's the slope of this line going to be? Well, it's going to be change in the vertical over change in the horizontal. And so this is V2 is going to be 0 meters per second. V1 is going to be 25 meters per second, and then T2 is going to be 15 seconds, and T1 is 10 seconds. Okay, for these 2 green points that I put down right over there. And so if we do the math here, this is going to be negative 25 meters per second over 5 seconds. And so this looks like it comes out to be negative 5 meters per second squared. And so that's going to be our acceleration at t equals 12 seconds, our instantaneous acceleration.